Okay, let's just start the video on contact lens design. So we were definitely going to talk about these factors. Okay, central thickness, total diameter, front and back optic zone diameter, and back optic zone radius, which is commonly known as base curve of the contact lens. And definitely one of the most important is edge design, in which we are definitely going to talk about edge design, shape of the edges and other factors, as well as what is edge lift and what is edge clearance. It's very important. And then material property, sometimes we call central thickness also in consideration. Yes, there is this. And sometimes we think about the water content and other things into the lens design consideration. Yeah, these are the factors. Okay, let's move further. So what about the lens design factor? Central thickness. Central thickness has a significant impact first in decay. Yes, decavity, basically oxygen transmissibility. So silicon hydrogel lenses vary widely in water content, but tended to have central thickness range from 0.07 to 0.09 mm. So it's depend on the company by company, depend on the material, depend on a lot of things. So we have to watch. So so rough for corneal, so suggested corneal thickness. I have taken this table from the Efron book. So it's basically rough minus 1, 0.18 mm, and so on so on. Okay, so add 0.02 mm in central astigmatism whenever contact lens has astigmatism made to basically cylinder greater than 2 diameter. So it's basically rough suggestion. Okay, so lens design factors, the total diameter. Total diameter means the maximum extent of diameter of finished contact lenses. So all soft contact lenses are fitted larger than SVID. So in rough soft contact lens is SVID minus 2. In rough corneal lenses are SVID minus 2. So soft contact lens SVID plus 2 and minus, sorry, in RGB contact lens SVID minus 2 is a rough guide, but it's not always there. Yeah, so basically, what is total diameter? Total diameter means, see, total edge to edge of the contact lenses. But you have to be cautious. There are other lot of diameters. For example, front optic zone diameter, one diameter. Another is back optic zone diameter. See, in back, so all diameter is not useful as a for vision. Which is useful for the vision? It's basically back optic zone diameter. Okay, that's why we call it optic zone. Okay, for front also, so all front the diameter, front zone diameter are not used for vision, but definitely front optic zone diameter, just remember this optic zone diameter, they're used for the vision. Yes, for the purpose of vision. So what other diameters do? For example, see, this is back periphery radius 1, back periphery radius 2. It means what? It means back surface is tricorp. Yes, first is back optic radius zone, second is back periphery radius zone 1, third is back periphery radius zone 2. So basically means there are three back curve, which means there are three diameters too, isn't it? The diameter of first curve and the diameter of second curve, the last curve, periphery curve, isn't it? So in total of the first curve, second curve, and third curve, in total diameter is known as total diameter. Yes, in adding first, second, and third curve diameter. So basically means second curve has its own radius, has its own diameter. Third curve means curve has its own radius and has its own diameter, isn't it? So roughly total diameter. So total diameter, it's really depend upon the contact, varies from contact lens to contact lens. Yes, see in this case. So now nomenclature is different. Basically, whenever the total diameter lands on the cornea, it calls contact lens lands on the cornea, it's called corneal contact lens. It lands at the sclera, it calls scleral contact lens. And a little bit part lands on the cornea and little bit part lands on the sclera, it calls corneal scleral. Yes, so I think it's old classification, that's semi-scleral. So diameter from 2.12.5 to 18 mm, so it's rough. Yes, so older classification and newer classification are different. So there are, I think there is paper in the nomenclature of contact lenses, especially scleral contact lenses. So let's move further. So this is a picture taken from this book. So a fitting guide, rigid contact lens, an approach, residence of contact practical approach, fourth edition 2002. And these pictures from this book are lovely. That's why I've taken all the pictures from this book. See, in this case, the optic curve basically means the curve responsible for vision by doing refraction. Okay, so optic curve, front optic curve means front surface of the contact lens, back optic curve basically called base curve. Yeah, periphery curve means periphery curve helps actually the role of peripheral curve is to mechanical support of the contact lens, basically fitting purpose. Yes, and edge is not sharp, is rolled. Yes, and between two curve there is a sharp, there can be sharp junction. So basically manufacturer do blend of that sharp junction. Yes, see junction. And it's very important that, see, periphery curve is there and total diameter is there, optic zone diameter is there. Yes, so the radius of curvature, mm, for base curve is 1, and periphery definitely it is flatter. That's why the radius of base curve is smaller. At the same time, radius of periphery is larger. Larger means, what do you mean by larger radius of curvature? It means flatter, isn't it? So definitely periphery is flatter compared to central base curve. So what do I mean by that is, if this is central base curve, then first periphery will be flatter than base curve, second periphery will be flatter than first periphery, and third periphery will be most flatter than these two, this overall three, isn't it? One, two, three. So first base curve, let's take a certain, and then second will be flatter than base curve, third will be more flatter than second, and fourth, if there is fourth, then fourth back curve will be most flattest. Why this is how we construct the contact lens? Because our cornea is prolate, isn't it? Prolate means center is steeper, periphery is flatter, and that's why we make such a contact lens. Because especially back surface, base curve is definitely optical curve, so which is very important, base curve or fitting curve, whatever. And by except from base curve are peripheral curve. Peripheral curve mainly helps in fitting relationship with the cornea. Yes, because cornea, as you move from center to periphery, it flattens. So you have to understand why first periphery curve is flatter than base curve, why second periphery curve is flatter than first periphery curve, why third periphery curve, if there is any, or last periphery curve, then it's flattest of all. So you have to understand this concept. Okay, fine. So that's what I am talking about. See, in this picture, it's very very beautiful picture. First, this is base curve. Yeah, this is back of the zone diameter is a zone diameter, and zone radius is base curve. See, first periphery curve radius is something like that. Second periphery curve is R1, that's R2. It's more flatter because R2 is more longer. Yes, why? I have already told you. So that's why we call it intermittent curve. Yeah, and the periphery curve, whatever. So first junction between base curve and first periphery curve, and between first periphery curve and second periphery curve is second junction. Yes, so it's something like that. So it's very important concept here is, I will definitely come this concept later on, because that's the concept of societal height. See, in this picture, so it's the same lens diameter. As you decrease radius of curvature from 8.4 to 7.8, as you decrease radius of curvature, it means what? Whenever you decrease radius decrease means increase of steepen. Yes, or maybe you understand by another word, increase in curvature, isn't it? Radius of curvature and curvature are both different thing, exactly opposite thing. So decrease in radius curvature means increase in curvature. So in this picture, whenever we decrease the radius of curvature, sagittal height increases. Yes, here sagittal height like this, here sagittal height like this, here sagittal height, here this is the sagittal height, here Societal height is longer. Here, societal height is longest. Yes. So that's the concept. So basically means if diameter is constant, if you increase the curvature or if you decrease the radius of curvature, what happens? Societal height increases. It's very important, this concept, because concept of societal height is very important whenever we fit any contact lens, but especially in scleral lenses. Yeah, see this picture, I love. We can definitely tell that this curve has larger radius of curvature, this curve has smaller radius curvature as compared to this, and this curve has even small less radius of curvature, but we have same diameter, 13 mm, 13 mm, and 13 mm. See, whenever there is a equal diameter but at the same time the radius of curvature is smaller, then societal height gets larger. That's the concept. Yes, radius of curvature gets smaller here, but at the same time societal height increases. Yes, so that's why if diameter is constant, yeah, for this diameter is constant 13 centimeter, so diameter means for the definitely for the contact lens. Yes, if diameter is constant but the radius is decreasing, at the same decreasing the radius, societal height increasing. What do you mean by decreasing radius? More curved, isn't it? So basically radius of curvature is inversely proportional to curvature. That's two different things, you must understand. A radius of curvature is inversely proportional to curvature. Smaller the radius of curvature, larger the curvature. It's very important. See in this picture. Now what happens here? When we increase diameter, yes, without changing radius of curvature. So radius of curvature is keeping constant. R is constant here. R is same. Yeah, but we increase radius of curvature. So sorry, we keep radius of curvature constant. At the same time, we increase diameter of that contact lens. So increasing the diameter will increase societal height. It's very important. So diameter increases, so societal height increases. What we do? We do R constant at all. R is constant. So previously we do diameter constant and we change radius of curvature. And then we look at the societal height. And now what we have done? We keep radius of curvature constant, and then we try to increase diameter and see what happened to societal height. Basically, why we are doing that? Because societal height is a central important factor for contact lens fitting. Higher the societal height, steeper the lens, and the steep fitting chances of steep fitting getting higher. So that when societal height is smaller, chances of flatter fitting definitely gets higher. Chances of flatter fitting. Yes. So see in this picture, what happened here? When we increase the diameter from 13 mm to 14.5 mm, and we know the radius is equal, so r equals r1 equals r2, this is r2, then what happens? Societal vault of larger diameter is large. Yes, societal height of larger diameter is large, and we know we keep constant radius of two circles. Yes, so that's very important. Okay, let's discuss about the lens design factors. What is front and back optic zone diameter? You have to understand zone diameter, and remember it's not just a zone diameter, it's an optic zone diameter. It's very important, it's an optic zone diameter. What do you mean by that? It means by the refraction from that particular zone will give good vision, and it has direct relation with the vision. Okay, so whenever you move to peripheral curve, you won't see that term optic, because peripheral curve are not related to optic or optical vision zone. Okay, The front optical zone diameter should be at least 0.5 mm larger than BOZD. Just remember this point. It's always there. Front optic zone diameter is larger than back optic zone diameter. So back optic diameter should be large enough to cover pupil in most conditions, including low illumination. It's always there. Why we do in case of preliminary examination, why we do pupil evaluation? Because we want our pupil in lowest illumination covered by back optic zone diameter. It's very important point. So in your viva, there are a lot of questions will come. Okay, in this. So this is a good point. You have to understand. An increase in BOZD of 0.5 mm, sorry, requires an increase in BOZR by 0.005. Why? To make sagittal height depth constant. So basically means, see, BOZR increasing means what? Means decreasing societal height. At the same time, BOZD increasing means what? Increasing societal height. So BOZR increasing by 0.05 decreases societal height at the same amount, equal same amount than 0.5, so 0.5 mm increase in BOZD. That's why, so whenever we increase BOZD by 0.5 mm, it requires 0.05 mm increase of BOZR. So what happens at the final analysis? Societal height, depth or societal depth, whatever, remains constant. Okay, it's very important. So what happens if BOZD do not cover our entire pupil? So at that particular condition, halos arise from the optical zone being smaller than the dilated pupil. Halos, why halos arise? Because see in this picture, one refraction from the optical zone and another unwanted refraction from the periphery zone. And there is a lot of light focused and defocused, and it will create halos. Just remember, it, it can be asked in your viva. Okay. So, base curve, I think elephant of the room. Yes, base curve means, so base curve on the back surface of the lens to fit the front surface of the cornea. So means base curve means what? Back optic zone radius, isn't it? Yeah. So it's measured by its radius of curvature in mm or diameter. It's always there. Very important parameter. Yes. So periphery curve, second curve just outside the base curve at the edge of contact lens. So it's, I have already told you, yes. So this radius of curvature is base curve, and what happened this, the first curve, and what is this, the second curve, radius of curvature. So typically flatter than base curve, approximate to the normal flattening of the periphery cornea. So why we do that? It's because normal flattening of cornea, normally cornea look like center is steeper and periphery gets flatter and flatter, which is prolate. So this type of, first more curved, second flatter, third more flatter. This is normally normal uh, contact lens pattern. But let me show you one thing. But what if first curve is this, okay, second curve is more steeper than the first curve. So second curve is more steeper than base curve. What happened then? Is this a regular contact lens design? No. Th- That's why we call this reverse geometry. What is on reverse? What is normal? First curve, base curve, is always steeper than any other curve. But let's take example of orthokeratology. First curve is flatter than second curve. It's usually it's not the case. That's why we call it reverse geometry. Okay, just remember whenever reverse geometry come, you understand that concept why it called reverse geometry. Because usually what happens, first curve, base curve is more steeper than first curve, periphery curve is more flatter than base curve, and second periphery curve is more flatter than first periphery curve, which means flattest of all. That's what usually is, because cornea is prolate shape, because cornea center is more steeper, periphery is more flatter. That's why we make contact lens to follow the corneal contour. But whenever we avoid that rule or deny that rule, but making what first curve, base curve is basically what you call it, flatter than second curve. Usually in second curve is more steeper than the base curve. In that condition called reverse geometry. Okay, so I think I have to stop here. It's 20 minutes already, so I'll make another video and I'll cover other half of lens design in half of the other video, I think, and part 2. So I think I have to stop here. So I think distance use.